Hallo en welkom weer hier by Farmspace. Ons is hier by HORSCH se Boeredag. Nou ja, kyk hy spuit daar agter my. En die ou wat daar staan het hom actually ontwerp. Dit is 'n Theodor Leeb hierso. Julle sal sien daar is die HORSCH Leeb spuit. So hy sê wat hierdie goeders ontwerp, hulle uitsort presies hoekom, waarom, wat. Kom ons vind uit hoekom is hierdie waarskynlik een van die beste spuite op die mark op hierdie stadium. Hi Theo, how are you doing?
Hi, I'm fine, thank you.
No, good. Right, so behind you, as I said, this is basically a culmination of a lifetime's worth of work. Explain to me quickly first off the HORSCH Leeb sprayers. How long have you been busy with this and how was the journey up until how you got here where you are today?
So the story for the sprayers here starts more or less in around about 2000. We have to build a sprayer for Michael HORSCH in Schwandorf, and the goal was to create a prototype, and if the prototype is performing well then it should go into serious production in Schwandorf. And there was a little bit of a delay and whatever and so on, and at the end it ended up that we take the responsibility for the sprayer and build the first prototype or second prototype of an 8,000 liter tank for farms mainly in East Germany, where we have the big structures in Europe. And it ended at the end in an own company, which is called now HORSCH Leeb Application Systems, which is a part of the HORSCH group, where we build the sprayers more or less for the professional farms over the entire world. That's our goal.
Okay, so when you looked at building a sprayer, what was the first things that it had to have? And so what was the basic principles that you built into the sprayer?
Yeah. So the first approach was more or less only performance.
Yeah.
And performance means tank volume to avoid a lot of logistics. Boom size. So we went up to 36 meter in 2001 or 2003, and spraying speed. So that was the main approach when we began. Only performance, and then we realized, okay, maybe this is only one part of the game. The more important part of the game is the efficiency of the chemicals itself.
Yeah.
So of course we need performance because the times to spray are limited over the day, but we want to also have a lot of the best efficiency of the chemicals, because it's expensive what we are doing, what the farmers are doing, and for this we want to have efficiency. And to find out what is the most important part to increase the efficiency, we started some projects with 2 universities in south of Germany, and the goal was to find out where we have the most loss by spraying. Is it drift? Is it evaporation? Is it because we are not hitting the crop or the weeds, what we want to do, what we want to have? And the result was that drift is one of the most critical parts, because what is drifting away is at the end evaporating. And we did some measurements in the wind tunnel with different nozzle setups, boom heights and so on. And at the end we found out that boom height is the most critical part. And to give you only an idea number, if you lower the boom from 50 to 30 centimeter, you can avoid 25% of drift.
Jeez.
And 25% more or less on your crop is a lot.
Okay, so then am I correct in saying that you've got almost 2 different components to a sprayer? You've got the spraying piece, as you say, the effectivity of the chemicals and so forth, and you basically need to get that thing as close to the ground as possible with the nozzles, let's say.
Yeah.
And then you've got the physical, I almost want to call it the logistics around it, in terms of how do you get the nozzle as close to the ground without hitting the ground, and without having the operator to physically have to do that manually and so forth. And then just the whole, let's call it the chassis, the steering, all the other stuff that at the end of the day makes this a high performance machine. Is that correct in what I'm saying?
Yeah, I think the most important part is the boom, of course, because the boom is distributing your chemicals. And I think it was in 2009 where we started an own boom control project. The goal was to develop an electronic system which is controlling the boom in a proper way. And at the end, what we find out is, after a lot of tests and trials in the field and trying different concepts, is that the boom itself never makes a mistake.
Yeah.
The mistake is always coming from the chassis. So if the chassis is moving left and right because of bad trim lines, you can see that the boom starts doing the same, and then you need a very high reactive control system to manage it. Yeah? And we did another approach after, I think it was after 2-3 years, to say, okay, if the boom never makes a mistake, why should we not leave the boom alone, more or less? So taking out each part which makes a hard connect or a hard connecting between boom and chassis, like a shock absorber, like springs forever in the center part of the boom.
Yeah.
We did this, made some trials, the boom was perfect, but sometimes you need an element which is controlling the boom because you want to run in a side hill, whatever, or want to adjust the boom in a certain angle. So you need something between chassis and boom. And then the idea came up with a very clever electronic guy to do the same like you have in your hands. You have a gimbal.
Yeah.
Where the phone is on, you can move your gimbal like you want. The phone is always stable. And this is the same technology here.
Awesome. Now, show me here at the back while we're speaking of that, because I think that is something that sets you apart from some of the other guys.
Yeah.
Is actually the boom stability on this thing.
You have to come here.
It's crazy. I just want to get a wide shot so that I can just show them. So the first component is you've got these shocks where it's mounted on the chassis. Eh? I'm saying shocks, the hydraulics. That's
The cylinders have a shock absorber system,
yes.
to avoid hard pushes from the chassis into the boom. And then here, this is the center part of the boom.
Yes.
And here you can see the 2 cylinders, hydraulic cylinders, which are controlling the boom.
Yeah.
Can see these 2 left and right, and that's nothing more. No springs, no shock absorbers, nothing. And these 2 hydraulic cylinders were controlled very, very fast by a high-performant electronic hydraulic system, so that when the chassis is moving, the cylinder is doing the same. So it's when the chassis is moving left and the cylinder is coming out, the other one is coming in the same time. That you have no force which is going into the boom.
That is awesome.
That's a
so
trick.
you've literally, and you've got like those small movements on those cylinders,
very fast.
And that basically counters
very fast.
Whatever issues you've got between the because this thing is almost, if I'm correct from the chassis, it's almost like what they say, the butterfly effect. The butterfly flaps its wings on the one side of the earth. So if you've got a little movement in the chassis, side, that equates to a big movement.
You couldn't avoid it.
And then with this, you basically just take that movement out and you're sorted.
The goal was more or less to separate boom from chassis.
Yes.
That's the secret behind. And,
such a simple
and to
solution.
do this, of course, we needed some sensors and so on, and a lot of software. But yeah, it works.
I just want to show them here quickly. So, vir die van julle wat nou nog nie gesien het nie, nê. Daai shock wat daar sit, nê, en daar aan die binnekant band en die ene langs hom. Soos dat die chassis se goeders dan nou deurkom, trek daai shock net in en uit. Ek sê nou 'n shock silinder. Maar dit is 'n tipe accumulator storie wat hy daarso het. En dan sort hy die boom besigheid uit. That is an awesome solution. Yeah. So simple.
And this with this technology now we are able to spray under 50 centimeter boom height.
Yeah.
And if you want to do this, of course, then you need a 25 centimeter nozzle spacing, because otherwise you have too less overlap and you're making stripes in your field. And with a 25 centimeter nozzle spacing, can lower the boom theoretically down to 25. In practice, we are working with 40 and 30 boom height, and this reduces the drift dramatically.
So in that way, you basically got the drift down to a minimum. So you've achieved your goals of actually being able to get the, as you said, effectivity on your pesticides and all of those things, because those are the things that at the end of the day cost a crap load of money.
It's very simple. Each droplet which is flying away is lost.
Yeah,
exactly.
Okay, and then I just want to know this plate that you've got in front here.
Yeah.
What is that for?
the plate here in front.
Yes.
It's to protect the nozzle mechanically, of course, and mainly from wind, from the wind because you're driving. Because we found out in tests in the wind tunnel, the critical area where the smallest droplets are going away from the fan is when they are directly coming out of the nozzle, when the fan is created.
Yes.
And if you protect this area from wind, you have a more stable fan. That's very simple.
Yep.
And for this is the plate here.
Awesome. And then just in terms of boom sizes that I do get on it, what are the sizes?
Yeah, this is a 120 foot boom.
Yes.
It depends a little bit if the customer is working in imperial or in metric system. We have a 36 meter boom, we have a 120 foot boom. We have also a 148 foot boom. This is 48 meters.
Yes.
Of course, we can go smaller to 30 meters. It's not a problem. So the biggest boom is 48 meter at the moment.
Cool. And then I see here you can put different nozzles on this.
Yeah.
So you showed something there inside of when you turn on let's say a headland or whatever the case might be. So that what do you call that function?
Curve compensation.
Curve compensation, right. So how does the curve compensation work, and how does that work with the nozzles and everything?
Yeah. In general, we have two different nozzle control system. This one here works pneumatically without electronic. Of course, we have electronic, but not on the nozzle. Maybe I can show it.
Yes.
Directly on the nozzle body, there is a small element which is more or less only a pneumatic piston, which opens with air and closes with a spring. Okay, and on this sprayer we have sections. We can build up to 42 physical sections, and we have different, different nozzle bodies. What I showed today was a system which is called 4+2. That means we have 4 nozzles, each 50 centimeter and 2 between.
Yes.
So 4+2. That gives you the opportunity to manage 6 nozzles, and you can do this manually, of course, to say, okay, today I want to spray with nozzle number 1, or nozzle number 1 and nozzle number 3 together in combination, like you want, or we can do this also automatically, because the system is knowing which nozzle is on which place and which size. So, and when you do when you're spraying in a curve, of course we are knowing exactly the speed of this section. And then we can adjust the nozzle setup or nozzle pair or whatever, so that you have the best application rate or the correct application rate for this speed in this section.
That makes a lot of sense. So it basically opens and closes. Let's say you'll get to a certain section, you'll have in the inside, you'll just have one nozzle going,
correctly,
and then you'll have 2 nozzles going a little bit further on, and then in the outside you've got all the nozzles open.
Maybe,
for example, but it knows exactly which ones to turn on and off, and so this thing can do math as well while it's.
Of course, it has to do math.
Okay, so that's the let's call it the technology side of things. And the way that works. What I want to know now is, let's come back to the practical stuff. Because this thing can have as much technology on it as it did. If it doesn't work practically, I don't want it.
That's true.
Right, so how do I refill it? How does that work? How does the pumps work? Give me a rundown.
Yeah, okay. So the main part is here. This is our injection hopper.
Right.
It's available in plastic like this here, or also in stainless steel.
Yes.
We create with this nozzle here a swirl.
Yeah.
So it's always wet here. So we also can fill in some powder or whatever. And this is to clean the tank, of course. Here you can suck in from a container, whatever, if you want. And to operate all the fillings and spraying, you can do it by this terminal here.
Yes.
It's on, it's off at the moment, or in the cap, of course. Here you can say, okay, I want to use the injection hopper, or I want to fill in here my water.
Yes, so that's on the water side.
Or you want to adjust the agitation, for example, system. It's also done via this terminal here.
Let me just, on the water side, just quickly, okay? If I go and I plug in something here, do I need an external pump that I pump it full with?
No.
Or I just hitch it on and it pumps itself full?
It pumps itself full. We made it's like a trick.
Yeah.
This is our main pump here.
Yes.
It's a centrifugal pump with a capacity of around about 1,000 liters per minute.
Yes.
In practice we have 800. And everybody knows that the centrifugal pump couldn't suck in when air is inside.
Yeah, because that was my next question. How do I bleed that? Because now that's going to be a...
And for this we made a trick.
Yep.
We had an additional pump, which is a piston membrane pump.
Yeah.
And the piston membrane pump can suck. Yeah. It can create under pressure. So, and the trick is now, if you are pressing this button here to start the filling process, the centrifugal pump starts running.
Yes.
And we have a sensor after the pump, and we see, okay, there is no pressure. Then the piston pump starts running as well and is sucking out, or more or less priming, your tube, your pipes, your centrifugal pump. And when this pump sees water, it creates pressure, we're measuring it, and then the piston pump shuts off, and then it's going fast.
That is so cool.
And the operator has nothing to do, only press one button.
So I don't, because this is really so important for me, because so I don't need tanks with extra pumps and whatever. I literally just got the tanks, they come here with the water, plug it in, poof, it fills itself up, there you go.
Yeah. You can suck out of, depends on the height of the machine. If we did some tests, 3 meters downside you can suck in.
From 3 meters down. So I need so I can literally just drive next to the borehole or the dam, chuck it into the dam. I just need a pipe.
Yeah.
I can have a wind pump that fills. This thing is awesome. Yeah. And it's got the filters and everything in there.
Yeah. Yeah.
So if I were to have some water that's got some quality, the filters will sort that out.
Yeah. And we use this additional pump here for cleaning as well.
Yeah.
We have it's a new cleaning process. It's called continuous cleaning. That means we clean and spray in the same time. Okay, it sounds a little bit crazy first. So the way it works like this: you spray until the main tank is empty.
Yes.
Then you press one button in your screen in the cap, and then the second pump starts running. And this pump has a connection to the freshwater tank.
Yes.
So it's sucking out clean water. Is coming in by the rinsing nozzle in the main tank. So the main tank is clean from the top, and the water which is coming down is immediately sucked out by the spraying pump, because it's running in the same time.
Yes.
And sprayed out in the back. So we clean and spray in the same time, and this helps us a lot to avoid failures.
Yes.
Or because of the operator doesn't know exactly which pipe is clean or not, so the system works completely automatically. Each line is cleaned. It saves time. The cleaning process normally takes 8 minutes, and it's very efficiency. We did a lot of tests and measurings how much residues we have after the cleaning process, and it's really perfect. Yeah.
And the thing is, because my operator conveniently forgets usually to do the cleaning part.
Or one line of.
Exactly. Yeah, but usually just for some reason just forget it totally.
Whatever.
Okay, so and then just I want to know
one more for cleaning. I think it's also important. We can do the boom cleaning independently from the tank cleaning. Yeah. For example, you spray and now rain is coming up, or it's too windy, whatever, and you have 2,000 liter chemicals in the tank left. But you want to clean your boom now. What to do? Press one button in the terminal. Then we have a circulation system in the boom. So we came in the middle with the chemicals, going out to the end and coming back into the tank. It's always circulating. So if we want to clean only the boom, then we bring in fresh water into the boom line when we know the volume of the lines, so that to avoid a mixing of water
Yes.
and chemicals in the main tank. So we press more or less the volume of the tubes with clean water into the main tank back. And then you have to only open one, maybe let us say 3 seconds, the nozzle, that the nozzle itself is clean.
Yes.
That's it.
And then it's done. And then I can go and park it until, okay, I can spray
and
again.
You
then
can be sure that there are no residues in the boom pipe.
That's awesome. So, and what I want to make sure is then just, okay, so I put in my chemicals in here, okay, and then it goes, does it have because you're talking about the fresh water and the chemicals, so I just want to make sure. So the chemicals goes into one tank on their own.
Yeah.
Okay, and they're kept there.
Yeah.
And then at a certain concentration, I'm saying, okay, I want to have so many liters per hectare of that concentration. Is that, and how does that work then with the fresh water? How do I know how much I'm
it's another way
spraying?
around. Of course, you have to set your application rate.
Yes.
Let us say 100 liters per hectare, whatever.
Yeah.
And then this system shows you how much liter do you need for a certain amount of hectare.
Okay.
Or you can fill it up completely like you want. Then the system shows you how much hectares you can do with the content of the tank. And how much chemicals you need. Okay, it's up to you.
Yes.
You have to calculate it. So
Yeah, but I just do the pre-calculations. We set it up, and then it pulls. And is it this tank? This is the chemical tank. Am I
no, the
correct?
chemical tank is behind. What you can see here is the freshwater tank.
Okay, that's
big
the
one,
freshwater
the top
one?
one. The
Yes.
top one, the high one is.
The top one. Okay, cool. So, and that one is 8,000 liters.
On this model is 6.
6. Okay, but it can go up to 8.
You can have 8, yeah. if you
Okay.
want.
So I've got a 6,000 liter tank there, and then this one is the fresh water that's on this side,
Yeah.
the smaller
Yeah,
one.
yeah.
Okay, so I pre-mix my chemicals, get that into it, and then I've got the fresh water
No,
stuff
the fresh
for
water is
cleaning.
only for cleaning.
Yes,
Only for cleaning.
That's only for cleaning and so forth.
Mm-hmm.
So I've got a pre-mix. Now I just wanted to make sure that it's not like a concentration feeder into the.
No.
Okay, no. Got it. Awesome. So and then I use that one just for cleaning, and then also how do I then fill up the fresh water one?
It's here. You can press it in here, or
Yes.
there's also an option that you can do it with the main pipe here.
So you can do it with that one as well.
Yeah, as well.
And does that also work on the same system then in terms of filling it
Yeah,
up?
yeah.
So, yeah, that is awesome. Okay, so now I know how to fill it up at least. Okay, tell me a little bit more about the chassis, steering,
Yep.
and I mean these. So when I went to Schwandorf, they were busy testing these stress testing the suspension on this.
Yeah.
Wait. So busy stress testing the suspension on these things. So
The
tell
wheelhouse.
me quickly, you know what we should do? Okay, before we get to this, let's head to the cab, and then we can pick it up, and then we can get in properly on underneath it. What do you think?
Can I do this?
Yeah. They were so kind to leave the key for us.
Maybe first a four-wheel steer standard.
Yes.
So we had no option with only rear-wheel steering. Four-wheel steering is standard.
Yes. So it's just this is how it
front-wheel
comes.
steering.
Okay.
Yeah. And we have for the height control we have more or less 3 options. You can have it in a 160 clearance rigid without any height adjustment. You can have it manually lifted up, so it takes around about 4 hours.
Yeah.
For guys who need the high clearance only once per year. And this is the highest option we're offering is an hydraulic adjustment that you can lift it up and down hydraulically.
So this is the Mexican offer. You
Mexican
get that?
offer?
Yeah, like
Okay.
those Mexican cars that go like up and down. That's
Yeah. Okay.
Mexican spec.
Okay. You close here. So I have to look if I.
En dan gaan ons julle nou wys hoe lyk die ding as ons nou mooi van onder af kan inkom. Dat ons gecheck hoe lyk die cab hierso. So currently you've got the class cab here, but you redesigned your. So I'm not going to spend too much here. You redesigned the whole
Yeah.
cab for basically a HORSCH cab. Am I correct?
Yeah. We have the new cap and the new armrest, which is available for next year.
Yes.
Yeah. We showed it on the Agrotechnica. Maybe you have seen.
Yeah. So yeah, everything there, but ergonomically still the thing is going to work very, very nicely. No issues there.
No issues, yeah. No issues. And the nice cap here is a little bit more options. On another joystick here. One point is important. We can use a lot of different terminals here, so it's fully isobus, and we can run also with several steering systems, GPS systems.
So if I want the Trimble in there, I can put the Deer, or if I want the Raven, whatever.
No problem.
Awesome. Okay, so let's check here at the bottom quickly. Okay, now it's properly lifted up. We can walk through it very nicely. Okay, so as I say, they were stress testing this thing when we were at Schwandorf. Just explain to me quickly the suspension system and how this works.
Yeah, the suspension is here. It's a pneumatic element for the suspension, and very important is we have here 2 hydraulic shock absorbers.
Yep.
To avoid a swinging, to calm the chassis down.
Oh, I'm with you. So you've also got them. If some of the others have just got the airbags.
Yeah, that's a difference. Yeah.
That makes a lot of sense. So you're going full Dakar on this one.
Yeah.
And then just in terms of the width and the height, how long? I mean, I'm literally walking. Ek bukkie eers hierso waar ek nou loop.
So this is now around about 2 meters. I'm 190. It should be a little bit more than 2 meters clearance. The track width, we have 2 versions. One is from 260 up to 350.
Yes.
And the other one is from 3 to 4. It depends on the farmer's needs, so we can offer both. Yeah.
And then what you want at the end of the, and just the last thing, you were telling me that with this sprayer, you've got a perfect 50-50 weight distribution at the end of the day. Why is that important?
Oh, yeah, it's a good question. Our goal was to handle bigger tank volumes. When we started in 2001, for example, and one point which is very important is load distribution to avoid damages in the tram lines or in the field. And that's why we have this front cap concept.
Yes.
The front cap concept has the benefit that the tank is between the 2 axles. So we have this 50% load distribution. And to give you a number, this machine has an empty weight of around about 12.5, 13 tons.
Jeez, that's light.
That's light for 6,000 liter or 8.
Yeah.
And the load distribution is 50-50. Let us say we have 13 tons plus 6 in the freshwater. Let us say 20 tons is full. Then we have 10 and 10 tons. We have some competitors with a mid-cap version, which has with 4,000 liter, 15 tons on the rear axle.
So then you get that when it's wet conditions, it just because it's
going over.
Literally 50% more weight on the rear axle than there is.
And the next point is the diameter of the tires here, of the wheels. We can use the biggest which are available on the market. So this is 2 meter and 18. That gives us a large footprint in the length.
And that everything of that makes sense. And I just forgot one question then. And almost I forgot the art. What type of engine do you
FPT.
use? FPT. So you've got the FPT engines. Just quickly, a reason why did you go that direction?
We had experience with a lot of other engine brands, and when we developed this machine, we had a look which engine is the most common engine in the agriculture business.
Yes.
And this is FPT. It's a lot of brands are using FPT. It's known worldwide, and it's a very reliable and good engine. Yeah.
And that's the thing, I can get parts for that
that's
thing
the reason,
anyway.
Yeah.
That's awesome. Theo, congratulations on this. I know there's a few bigger models and so forth. The farmers can find out about them. But congratulations. I really think you built a game changer here. Well done.
Thank you very much.
Right, so dit is Theodor Leeb van HORSCH Leeb spuite. Hy sê oor daai ding brainchild, whatever ook al. Luister, maak 'n draai by HORSCH, kyk hierdie ding, se awesome spuit. Dink regtig jy is ook een van daai. Ons het dus in 'n jaar van game changers so afgelope 2 jaar. Dit's baie cool ding. As jy net 'n Marcus vir 'n spuit praat met hulle, hulle gaan hierdie ding toets, hulle gaan hom demo en te kere gaan seker maak dat hy reg is voordat hulle nou die goed inbring, maar praat met hulle. Dink nie jy sal spyt wees nie. Dis hier van Farmspace af. Tot volgende keer. Groete.